Hello, everyone. I'd like to welcome you all to this 2 p.m. session of the Lightning Chairs, where myself, Mark Tinker, will be hosting you together with Afifa Abbas. Just to get you started on some housekeeping before we get going. Just to remind you that we all need to be mindful of the Code of Conduct, which is published on the Apricot 2021 website. And I'm also just going to post the link to that in the chat room for everyone to see. Thank you, Dan, as well. And then if you have any questions or comments, please use the Q&A button on the Zoom for text, and I will be happy to read out those questions and comments on your behalf to the speakers. For any other questions about the event, or if you have any issues that could be related to the presentations, please use the regular Zoom chat. And you can also get more details about some support on the Apricot 2021 website. Please share your photos on Twitter and Facebook using the hashtag Apricot 2021. In case your question hasn't been answered during this session, you're welcome to email it to secretariat@apricot.net. That's secretariat@apricot.net, and we'll forward those on to the speakers. If you're facing any technical issues, we recommend that you also download the Zoom mobile app as a backup, and recommend that you use the headset so you can maximize your experience. For any queries or questions that are unanswered during this Apricot session, technical or non-technical, please email secretariat@apricot.net. And also for other Apricot sessions, you may refer to secretariat@apricot.net or pc-chairs@apricot.net. And with that, I will gladly hand you over to Afifa so she can get us going. Thank you very much.
Thank you so much, Mark. Hello, everyone. Welcome to the Lightning Talk session of Apricot 2021. I'm Afifa Abbas. I will be co-moderating the session along with Mark. Today, we have a lot to hear from all our speakers. With that note, I would like to invite on this virtual stage of Apricot 2021, the first speaker, Renio Topacio from DICT, and he will be shedding light on CERT-PH response and countermeasures on cyber threats affecting ISP. And with that, I would like to remind all the speakers that each speaker will get 10 minutes of time, including the Q&A. So requesting all the speakers to be mindful regarding the timing. Over to you, Renio.
Hello. Can you hear me?
Yes, we can hear you.
Yeah. Can I share my screen now?
Yeah. Yes, please. Yes, we can see your screen. Thank you.
Okay. Thank you very much. Good morning, good afternoon, and good evening to everybody. I'm here to present the CERT-PH response and countermeasures on cyber threats affecting ISP. By the way, I'm Renio Topacio from the Department of Information and Communications Technology of the Philippines. Currently, I'm the Deputy Chief of the CERT-PH and concurrently Section Chief of the National SOC of the Philippines. Also concurrently, I'm the Section Chief of the BAPT and Digital Forensic Section of the CERT-PH. The CERT-PH background, we call ourselves as the Philippine National Computer Emergency Response Team, or CERT-PH. CERT-PH is recognized under the Carnegie Mellon University as the authorized user of the trademark CERT-PH. It launched February 2018 and currently it's 3 years now. Under the DICT Department Circular 003, Section 1, use the term the Philippine National Computer Emergency Response Team, or the CERT-PH, shall lead, manage, and oversee the various government, sectoral, and organizational CERT. Also, we are the responsible in receiving, reviewing, and responding to computer security incidents, reports, and activities nationwide. who we serve? We serve public and private entities nationwide in the Philippines. Here are some of the frontline services we conduct. We have the incident response, cyber threat monitoring and information sharing, vulnerability assessment and penetration testing, security, and the Security Operations Center. The incident response also respond and handle cybersecurity incidents, received and detected by the team, and provide assistance to stakeholders for remediation. We also have the frontline service with the cyber threat monitoring and information sharing, collection and analysis of data from publicly available sources like Shodan, Shadow Servers, Team Camry, uh, public feeds regarding cyber threats in order to release daily cyber threat feeds, and public security advisories for the mitigation of cybersecurity risk. We also have the vulnerability assessment and penetration testing. We conduct cybersecurity-related assessment on network and online systems, web and servers, VAPT, to discover any existing vulnerabilities that can be exploited by adversaries. Security Operations Center serves as the centralized facility for monitoring, detection, and rapid response to security incidents and to the connected agencies. Here are some of the data from last year, from January to December. From the incident response, we responded 939, mostly from the government sectors. From the monitoring, we monitored threats from the public source, public feed, 65.7% from the vulnerable services, malware infection, and botnet. Vulnerability assessment and penetration testing, we conducted 698 from the systems, and total number of requested BAPT service is 40. From the Security Operations Center, we able to issue for 41,855 monitored incident and alerts, 970 alerts recorded. From the ISP, how do we address cybersecurity threats from involved ISP? We have the answer to external organization report and communications procedure diagram. I will cite example for this. Example, we are other certs reported to us that there's IP address involved in the Philippines that is currently ongoing DDoS attack. They reported to us, and then from the event, VEC, validation, evaluation, and confirmation, we validate the said IP address if is from the Philippines, and if verified or if false positive, we just document the report, and if not, and we assign incident ticket, and then after assigning incident ticket, we coordinate to the external organization from handling to mitigating the said incident. After the procedure, we create the incident report and documentation, and then we after that we close the ticket and document it. That's how we manage to the reported incident to us. Here are some CERT-PH initiatives. We provide technical assistance and capacity building to all CII, critical information infrastructure in the country. Also, we have this annual national cyber drill we conducted last November 2020, last year. Also, we providing daily threat intelligence feeds and providing CERT-PH as security advisory from all the entities, stakeholders. International collaboration, trainings, and seminar drills and exercises. Also, we coordinated incident response with CERTs and other CERTs in the ASEAN region. Cybersecurity-related information sharing, ASEAN-Japan online community tool. Also, we are in the process of the implementation of the Chubame project, the project of the AP CERT. the Asia Pacific CERT. Actually, that's all of my slide, and this is our international collaboration. We partner with the we are members from the AP CERT, coordinated with JP CERT. We have feeds from the monitoring from the Chubame and also from Shadow Server and Team Camry. From the annual cyber incident drill from the CERT also, and the ASEAN Japan Cybersecurity Capacity Building Center, and also from ITU Cyber Drill and Bizone. Thank you. That's all. If you have any questions, you can ask, or you can email me at my email at renio.tapasha@dict.gov.ph, and also from CERT-PH at dict.gov.ph. Also, you can check our website. It's www.ncert.gov.ph. That's all. Thank you.
Thank you so much, Renio, for your wonderful expression. I do not see any questions for you right now, so thank you so much for your presentation. With that note, I would like to, I would like to invite, sorry.
Sorry, it's okay, actually.
Okay. With that note, I would like to invite our second speaker of this lightning talk session, Terry Switzer from IO Networks, and he will be speaking on understanding hosting trends in APAC region from local domains perspective. Over to you, Terry.
Thank you, Afifa. So just to check, everyone can see my screen?
We can hear you, and yes, we can also see your screen.
And you can see my screen. Excellent. And nice red dot. Perfect. So this fortuitously is a project landed in my lap during COVID-19 and my break from working last year. Good friend of mine, and I think a great friend of the industry, Aftab Siddiqui, asked me to start looking at how country code TLDs, or the top level domains of various countries around the region, were making use of their websites and how they were hosting them either internally or externally to their countries. And that proved to be a very interesting question to ask, because we found that there are country codes where a vast majority of their domains are actually hosting websites far outside the country. And that meant that there may be some recommendations or some trends that we can talk about. Now, all of my data at the moment is very early stage. We've only just finished compiling the database, but I'll take you through a few different things, mainly the tool set, the methodology, and I'll also look at some of the basic data and some of the basic visualizations that I've started doing for the report before handing it off to ISOC. So tooling, well, I think most people in data science, if they're writing scripts, they're going to end up using Python in some way. And a friend of the project, Danish, actually wrote a set of Python scripts for gathering data for us. I've then been collating the data and loading into Postgres, hosted on, of course, Google Cloud Platform. And as far as my visualization work is concerned, I always tend to go to Tableau because I'm a bit of a Tableau fan. So as for methodology, as I said, Danish's scripts go out and grab DNS glue. In this case, we get an A record and we get a quad A record. So we're looking for IPv4 and IPv6 addresses for these websites. We're sending them a ping, and we're also trace routing them, but we're doing a TCP trace route to their HTTPS port. So we're getting v6, v4 latency and hop count in the raw data. After doing some load and transformation work with this, I'm also marrying that up to, of course, RPKI data, validity especially. And because this is about what is crossing national borders, I'm using the Maxmind database for the geolocation. So we have a very simple little dump of the basic data as it comes in there. That's a bit of Postgres for those who recognize it. And then, of course, when we transform that, we end up with database rows that look very much like this. So we have an IP address, we have latency in milliseconds, we have hop counts, and then we have either a v4 or a v6 address. The country, in this case, is the .au on the domain. The network is the network that we find in the national international routing table, in this case ASN, AS name, and of course which country the IP addresses are allocated from. And it's important to make a note here that due to the prevalence of various providers, especially like Cloudflare, they may have ARIN IP addresses, and we might think that they're geolocated in the US, but they're actually using those all around the world. And you can see straight away from the latency in that second column, they're not possibly serving these pieces of data from the US, when in Sydney it's taking only 1 millisecond round trip time. As you can see too, that we don't always get a perfect set of data, especially with IPv6. Not every hosting provider we went to could provide us with v6 in every country when we're doing our tests. A good summary of the data. As you know, we tested 10 different countries, so AU, BD, ID, IN, JP, MY, NP, PH, SGTH. We tried to do Fiji, but we couldn't get any resources there. As you can see, most of the domains are either in Australia or India, Japan, as far as tests are concerned. This is probably directly proportional to the amount of development internet-wise in these countries, but I'll let others make their conclusions after we present the data in the report. The database itself has 4.6 million rows in it of this, and you can see that when we go to look at where these 10 countries are hosting their TLD domains, we're actually finding that they're hosting in 97 different countries, which surprised me. I thought people would have been hosting some of this content much closer to home, but there's some interesting examples like finding Indian domains hosted in Brazil, and further afield than that. With the ROA data, not many of these domains are on networks which have ROAs, which surprised me too, because the percentiles are actually quite low. I would have expected there to be maybe a 50-50 split, or a split that essentially matched what the deployment looked like in these particular countries. But unfortunately, it looks like web hosting and in-country ROAs are, well, they're two different things, they're two different pieces of data, and we're definitely getting, I suppose, a shortfall in the uptake of hosting companies actually doing route origin. So that was of interest. Another thing that came out very quickly in the data was, especially with Australian domains, even though there's 2 million unique domains, we found that 775k odd domains had no actual DNS glue to a website. So those domains had either just had plain old MX records associated with them, or a CNAME of some kind, but they were essentially didn't actually have a website associated with them. They were just being either held or being used for mail relay. So I thought that was a very interesting takeaway. IPv6 address space, or use of IPv6 address space for hosting, these percentiles are also, in my opinion, extremely low compared to the take-up of v6. So maybe some of these hosting companies who have the CC/TLD business need to ramp up their IPv6 deployment. Now, time for some visuals, because I love doing Tableau visuals. So what have we got here first? Well, our source countries mapped with number of domains. And I note here that our brief was to look at what these CC/TLDs were doing in country via IXP and other means to get to their websites. So 10 unique countries hosted across 97 different countries around the world. And some of these are interesting. I couldn't work out what this 9 was originally, but I worked out it's actually the Seychelles, and it's actually one of the public domain registry locations. And their servers are not in the Seychelles, their company registration is. So MaxMind has them located in the Seychelles, even though they are everywhere around the globe anyway. So that's one thing I need to sort out with the data, actually try to move the data or move these international locations where the hosting actually is happening, as opposed to where MaxMind thinks they're actually happening. So that's one thing I have to fix up. One of those your mileage may vary moments here. Now, Phil saw these the other day and said, oh, I like these. What are these? Well, these are bubble maps. And what I wanted to do was see who hosts these domains. And no, there's no surprise, obviously, if you're paying someone to host your domain, it's going to be someone like Amazon or Google or Cloudflare. But other names pop up here that we in Australia don't know as well. And I thought, okay, well, who are these other guys? So it turns out Japan has a very active hosting ecosystem with companies like GMO and Sakura here who are hosting. And of course, NTT, who's known around the world. So that was of interest. But there's one company down here I found fascinating. This is company Wix. Now, Wix did a lot of TV advertising in Australia to build up clientele here, and we'll have a look at their network metrics later on in the presentation. That was fascinating, what was happening there. Look at Nepal and Indonesia.
Terry, just to interrupt you a bit, you have 2 minutes left.
2 minutes? Okay, cool. I'll speed it up. So in Indonesia, again, we see there's a very active hosting ecosystem there as well. Trying to do a top end, we see that as far as networks are concerned that are hosting, it's the usual suspects, in my opinion. People like GoDaddy, Google, Akamai, and so on. Numbers. So I think Cloudflare probably has the best looking network metrics in the database. And that's mainly because of the way they're deployed. They are deployed at 1,000 internet exchange points across the globe. So they've managed to take that crown very easily. But as I mentioned, Wix is complete opposite of that, unfortunately. And what I've seen with Wix is they literally have thousands, tens of thousands of domains hosted on 21 different IP addresses, all located in Northern America. So they're putting all their eggs in one basket as far as that's concerned. Looking at Amazon and also looking at Google there, you can see that they're hosting everywhere for everyone. So that's just a comment on how much market share they have. But ultimately, I wanted to look at who was also doing the most V6, and of course, it's Cloudflare. They're essentially keeping their latency low. They've got thousands of IP addresses active, serving up content, which is great. So a quick special mention for a few of our characters. As I said, Dinesh helped us out with the code, and we've been running his code for the testing. Aftab is my project sponsor there at ISOC. And one of our hosting companies went to great lengths to look after us. That was ZenLayer. They gave us 7 different locations across the region to test from, and they also managed to make sure most of those locations had very good access to IPv6 as well, so we could get good data there. But yeah, thank you very much for allowing me to summarize. Yeah.
Thank you so much, Terry, for your wonderful expression and presentation. I also see do not question for you yet. So with that note, thank you so much again.
Thank you.
Next, we would like to invite on this virtual stage Geoff Huston from APNIC, and he will be shedding light on new ROA measurement dashboard.
Thanks all. You can start the clock now, and I think 10 minutes is actually way too long. This will be relatively quick. There are a number of questions about ROA deployment and routing that, I think are interesting questions to ask. With all of this push to get folk to sign their routing objects with ROAs, how far have we reached within each economy? Where are ROAs getting deployed in terms of the routing system, and where are they not? Equally, when you look at this, how many are valid, how many are invalid, and how many aren't there at all? And as you're probably aware, address spans and route objects are very different things. I can do a ROA for a /8, and that's a huge amount of addresses, or a ROA on a /24, and it's merely 256. So if we change the view to look at advertised address spans, what do we see? And of course, mixing it up a little bit, how about V4 and V6? So what we've done is actually produced a report very similar to the ones we do on IPv6 deployment, on DNSSEC, and a couple of other related metrics, and look now at ROA deployment. And this is, the typical world map. But what we're looking at is the greener you are, the more of what you advertise is actually covered by a valid ROA. Now, this is an odd map in so many ways. The US, non-existent. Canada, even less existent, 7.14%. Brazil, 9.68%. Interestingly, in South America, all of the western part of the continent, particularly up in Peru, Venezuela, Colombia, and Uruguay, but not Brazil. Very odd. Over to Europe, Portugal big, shocking on V6, but really big on rowers. Turkey, almost 100%. Oh my God. Iran, 88%. Pakistan, 85%. And Nepal, 89%. Bhutan, you just see it there at 95%. Mongolia as well. But not India. Massive on V6, but only 40% on rowers. China, 2%. So it's such an odd map. It's not really all about GDP and richness. There's something else going on that drives this. If you want to look at this later, there's a QR code, you can go there. And if you're wondering about the data, if you look at that page, you actually see a huge amount of data behind it. We actually count valid, invalid, and unknowns in terms of routes and addresses. So the data set we use underneath this is exposed. This is updated daily. So the data comes for today. Tomorrow, the numbers will change. You can drill down as far as you like. This is a country view. I should note that there are a number of folk doing this, including Hurricane Electric with Anurag. Numbers differ slightly, and they differ slightly for two reasons. Everyone's view of BGP is subtly different, and there are routes that you might see that I don't, and routes that I see that you might not. That's the first problem. The second issue is, as Terry fleetingly mentioned, geolocation is a nightmare. And certainly the geolocation I'm using here is a highly modified version of MaxMind, where a number of quite plainly overt errors are kind of repaired in a little running repair file where I try and improve the accuracy of the basic MaxMind data, because MaxMind is fine for about 90–95% of the time, and off with the pixies for the other 5%. So yes, if you see this in other reports from other folk, you might find some small and subtle differences. But you can drill down into countries, and of course you can drill down into individual networks. And so this is Telstra's effort in Australia, the blue line, as compared to Telstra, the country. And what you actually find is that Telstra turned on its own publication of rowers late in 2019 and has maintained that ever since, whereas the rest of the country is taking some time to catch up with what Telstra has managed to do. Still being developed and debugged. And so at this point, it's pretty elastic, and it's certainly got my attention. And so if you see anything, A, you want, B, would be useful, and whether I can actually do it in code, please get in touch with me and I'll see what I can do. But by all means, have a play. I should also take the time to remind you that there is a second and almost a sister report on this, which is actually the opposite side. So the rowers are the production factory, but the other measurement is actually the use factory. And what this measures is for users inside countries, economies, inside networks, how many of them can reach a site where the only way of getting there is by following a route whose rower is invalid? Now, admittedly, that's a tiny map, but what you notice is one of the few that are left showing green is Denmark and Morocco. And a huge amount of the rest of the world is not doing very well at all. So while there's a fair amount of deployment of rowers, the extent to which folk are willing to obey and drop invalid routes is actually far lower than we'd suspected. We're now using a massive Anycast cloud to do the checking in both V4 and V6. And so if there's a way to get to this invalid route, the testing system will find it. So when you're doing drop invalids, this is a pretty harsh test. And we've certainly uncovered a few areas where there are implementation issues and operational issues where folk thought that they had it on, and it turns out it wasn't quite on as they'd thought. And if you look at some of the graphs that we've been doing, you'll actually see a bit of ups and downs. And I have time for questions, I believe. So if you've got any, I will happily take them or hand over to the next speaker. Thank you.
Thank you, Jeff, right on time. But we do not have any questions for you yet. So thank you so much for your wonderful expression and contribution. With that, we will move on to our next speaker, Artem Tereshenko from VAS Experts, and he will be speaking on botnet versus CGNet. Over to you, Artem.
Thank you. Hello for everyone. Do you see my screen?
Yes.
Okay, great. My name is Artem. I am from telecom software developer company VAS Experts. Right now, I will share a case from our work. It is about detecting botnet in the network with CGN, carrier grade NAT. At the Apricot conference, the topic of IPv6 has been discussed in many papers and tutorials. A lot of countries in Asia have great success in IPv6 adoption over the last years. The only correct conclusion is to continue IPv6 implementation and switch to IPv6 only networks step by step. But IPv4 is still here, and we need to work with these, and new addresses will not appear. So the operators have to implement CGN and use dual stack IPv4, IPv6 in order to support both versions during the slow migration process. CGN brings its challenges to peer-to-peer protocols and online games, but most of them are solved by choosing a carrier-grade NAT solution with ILG support, application layer gateway. The main task of CGN is to effectively use the limited addressing space of IPv4. When a client receives a private IP, he is able to use 65,000 ports. When the ISP implements the CGN, the subscriber usually gets 2,000–3,000 ports. If the client reached the limit, then the quality of service degrades because there are not enough ports for new connection. Why would you think that 2,000–3,000 ports are enough for a subscriber? This comes from our practice. Usually an average user generate 50–60 connection at the same time. So in 30, you can translate up to 1,000 private IPs to one public IP, but this actually a bad practice. We recommended to translate not more than 100 addresses, but better is up to 10 private addresses for one public IP. This will not cause oversubscription. Of the case when popular services like mail, video CDNs or search engines use protection against botnet attacks network based on IP addresses. The problem is that when they receive too many requests from one address, they consider it is attack and block some requests or turn on CAPTCHA, which is usually inconvenient for subscriber. According for our experience, 2–3,000 ports per subscriber is optimal, taking into account all the special aspects of CGN. But even if we allocated the ports correctly, there are cases when the client with normal use of services experience quality degradation. This reason can be first, client-side virus activity that occupies all three ports. Second, this is hacking devices to use them for botnet. So there are also no free ports. And third, this is incorrect behavior of IoT devices. For example, the smart lock or other smart device tries to update the firmware and creates up to 4,000 outgoing connections. There are two ways to solve this problem. First, this is increase the limits. Add more ports per subscriber, but then you have to use more public IPs. The cost of CGN implementation become questionable. As a result, clients with parasitic activity will continue to experience degradation of quality. Second way to solve this problem, we recommend to be proactive and always carry out additional analytics using deep packet inspection system or similar. We analyze traffic, generate the full net flow, build clear triggers to find the problem and work with them to fix the issue. Our task is to retain the client and increase his loyalty. In this slide, we are analyze one of the IP address that had all 3,000 ports occupied. We see that over the last 15 minutes, he created more than 10, more than, more than 100,000 session with which clearly stands out from the general statistic. We need to start working with this client as soon as possible. Otherwise, he will switch to another internet provider very soon. Triggers for finding these problem clients can be the number of packets per second from the subscriber, average session time, and some other. A lot of clients use the solution on their networks and its work. To sum up, carrier grade NAT is already used and will be used even more by operators in the future. But the technology has its own restriction of number of user session. We recommended to explain the list. We recommended to expand the list of analytics and management tools and keep your quality of service high. Thank you for your attention. If you have time, please share your question or opinions on such a case.
Thank you so much, Artem, for your presentation. Let me check if we have any questions for you. Well, not yet, but I think if audience wants to ask any question, they can always mail to secretariat@apricot.net. With that note, I'm thanking you, Arkan, for your wonderful presentation. And moving on to our next speaker, Kitinan and Thanapat Masnisa from BKNX, and he will be speaking on running hybrid meeting switching platform. Over to both of you.
Yes, thank you, Afifa. Let me share my slide. Oh, sorry. Okay, did you see my screen now?
Yes, we can see your screen.
Okay, cool, good. So, hi everybody again. My name is Kitinan, and today we are together with Thanapat. We are from BKNX. So, today we believe that many of you also enjoy a much technical session from the Apricot. So, for our topic is a little bit off the topic. It's not much in technical. So today I will talk about what we have done at the beginning of this week. So to how we're running, we call that hybrid meeting switching platform. So let's follow us to see our journey, and I hope you enjoy. So first of all, we would like to say thank you to Nisara Tanskun from Interlab. She is the one that also contribute to our solution and also give us the equipment, the mixer, for us to complete this project. So start with the new norm of the physical event. We know that during the COVID situation, so most of the event cannot held the physical event. So most of event move to switching to the online or virtual platform. So later on, when the situation is better, so some area can reduce the restriction, and some area can possibly have a physical event with the limited people. So later on, we may see that they need a new word of the hybrid event. That means there are participants that can join from both online and in the physical event mixing together. So from our expectation for this kind of the event, so when we would like to run the hybrid event, so the thing that we would like to consider is first is the audio. So when we have the people from different locations, we would like to make sure that all the participants from our location can hear each other clearly. And the second one is quite interesting to avoid the non-looping sound, because the sound from each system can be looped if we didn't prevent or didn't avoid that. So we can make this full platform failure. So that is the two things that we keep to consider when we try to combining this kind of event together. And for the video side, so we would like to achieve three things. So we from the video, we would like to see the presenter slide from on-site event, and and the second, we would like to the presenter from the platform one can also share the screen to our participants, and as well as the presenter from the online platform too, they can sharing their screen to other participants as well. So next, let's look into the software that we use. So the first one we use Open Broadcaster software, or OBS. So this is a kind of software that can manage the screen, and we use that as a receiver size to make the scene, and together with the NDI, that is the plugin of the OBS that can receive the screen from other station with a network. That is a two bunch of software that we use in the receiver side. And for the sender side, we use the vMix. It's the software that can cast or can inject the screen to this receiver over the network. So another software we also looking to use the vClass. vClass is built on top of the big robot phone. That's the open source web conference platform. And especially vClass is also support EAI. That is a local email in our local language. So we think that vClass can support more participants that didn't have the English email, and also support Thai language locally. So yeah, that's it. The thing that we would like to combine the vClass to the other popular online platform too. So let's take a look at the hardware side. So as I mentioned, the thing that is needed to achieve that is a sound mixer. And the sound mixer has to achieve the option that they have to have more than one output group controller. So we can say that this mixer can separate to more than one channel. Like if we have the people from group one, they can get rid of the sound from second channel, and if we have the group two, we can get rid of the sound from the first channel. This is the functional of this mixer that we have to use for this setup. And also we need the laptop and PC that install a bunch of software that we use. And if it has the GPU, we highly recommend. So let's take a look at the diagram of Thanapat. We will show you after this. Okay, over to you, Thanapat.
Okay, hello. Okay, first, a physical meeting usually has a presenter connected to the projector and a microphone in the room. Yeah. Then we have going to bring participants from Zoom to our setup using the software that we mentioned to send and receive screen from the presenter. Yeah. Then we have to manage sound in and out of the system. We connect the sound from Zoom to the mixer and receive the sound from the mixer and cut the sound from Zoom itself to avoid sound looping. Okay, then we will take the sound from the on-site or room to the Zoom by connected microphone to the mixer and adjust the sound from all channel to room speaker. Okay, so, oh, sorry. So now we have done combine on-site and Zoom conference. Okay, next, let's combine another conference platform, which is eClass. Okay, we apply the same setup from Zoom to eClass setup.
Team, you have 2 minutes left.
Okay, thank you. Okay. At this point, both conference and on-site will be able to talk and interact with each other all the time. Okay, with this setup software, we can send and receive screen from each station over the network, the other way around. Okay, this is the setup that we use in the past kind of meeting. Okay, next, scenario 2. We want to bring another meeting to our current setup. This is what we have done in kind of meeting. There are 2 conference Zoom meeting. One is from Apricot and one from Thailand, and also one from VCAT at Thailand and on-site participants. From scenario 2, we just cast screen from Apricot session to each station to work together. Yeah. Like that you see in slide.
Okay, to wrap up, so the lesson that we have learned, so we know that we can achieve vClass and Zoom is working fine for remote participant and from on-site, and yeah, we can combining 2 platforms together, and also we can bridge 2 meetings from the same platform as well as bridging the other platform in other platform as well. So for future work, I think we can bridging more than 2 or 3 different meetings. Yep, and I think we maybe the kind of software that do something like this in the cloud, or maybe a turnkey solution, or you can streaming this kind of the event to the social network platform or online platform as well. Thank you very much. So if you have a question, so please.
Thank you, team, for your presentation. That was insightful. For now, you don't have any questions from the audience. Thank you again. With that note, we are at the end of our lightning talk session, and we are done with all the presentations. I would like to thank all our audience and our speakers for your contribution. I hope this session was insightful for you all, and handing over it to Mark for making some announcements. Thank you again.
No, thank you so much, Afifa, for moderating that. And yeah, unfortunately, we don't have any questions going forward. No special announcements from my side. Just remember that the presentations and slides have been recorded, so you can always refer to the website if you want to pick them up. Don't forget to make your poll as to how the session went, and do let us know how we can improve for the next session or for next year as well, through the poll and through email as well. Okay, that's about it. Thank you very much, and we look forward to seeing you very soon.